In the previous session, we looked at cos theta plus I sin theta to the power of n is equal to cos n theta plus I sin n theta for n in n sub naught. So now let's look at what the expression would be when n is a negative integer. So let's start off with z is equal to cos theta plus I sin theta, and let's figure out what its inverse is. Now to figure out the inverse, let's multiply and divide cos theta plus I sin theta with its conjugate. Now multiplying this, we get cos theta plus I sin theta times cos theta minus I sin theta. Right? A plus b times a minus b equal to a square minus b square. So cos square theta minus I sin theta square divided by cos theta minus I sin theta. Now simplifying it further, we get cos square theta. Here it will become I square, and I square is minus 1. So minus 1 times minus is plus 1. 1 we don't have to write. So plus sine square theta divided by cos theta minus I sin theta. Now cos square theta plus sine square theta is equal to 1. So we have 1 by cos theta minus I sin theta. But remember, z is cos theta plus I sin theta. So bringing the denominator to the other side, we get cos theta plus I sin theta times cos theta minus I sin theta is equal to 1, which means that the inverse of cos theta plus I sin theta is cos theta minus I sin theta. So if n is in n sub naught, implies that minus n is in the set of negative integers. So cos theta plus I sin theta to the power of minus n can be written as cos theta plus I sin theta to the power of minus 1 to the power of n. And cos theta plus I sin theta to the power of minus 1 is nothing but its inverse. So that is, we have already shown cos theta minus I sin theta. So we have cos theta minus I sin theta to the power of n. In the previous session, I forgot to mention one particular aspect. So we saw cos theta plus I sin theta to the power of n is equal to cos n theta plus I sin n theta. But I forgot to mention that similarly cos theta minus I sin theta to the power of n is equal to cos n theta minus I sin n theta. So cos theta minus I sin theta we have here to the power of n. So that would be equal to cos n theta minus I sin n theta. And since cos minus n theta is equal to cos n theta and sin minus n theta is equal to minus sin n theta, we get cos n theta minus I sin n theta is equal to cos minus n theta plus I sin minus n theta. So that implies cos theta plus I sin theta to the power of minus n is equal to cos minus n theta plus I sin minus n theta. Thus, we have shown that cos theta plus I sin theta to the power of n is equal to cos n theta plus I sin n theta for n in the set of integers. In the previous session, we had shown it for n sub naught. Here we have shown it for negative integers. So that means we have covered the entire set of integers. By the way, this is nothing but De Moivre's theorem, which says for n in z, cos theta plus or minus I sin theta to the power of n is equal to cos n theta plus or minus I sin n theta. And this is a very, very important result, as we will see in the next few sessions. If you found this session helpful, please do like, share, and subscribe. Comment suggestions are always welcome. Thanks for watching. See you in the next session. That's it for now.